Hello everybody, how's it going? Our lesson today it's about data type, sizes, and ranges. If you remember in the homework of variable lesson, I say it's not ideal to use integer data type with small values. We used before in our previous programs and homeworks. We use integer data type, standard integer data type, int, and after that we declare age variable equal 33, 32. We assign to the age variable a small values. It was represent that number or that values. It was represent human life ages. Even if human life ages value was bigger than 150, 200, 300, 20,000, 32,000, it's not also ideal to use these values with integer or standard integer data type, because standard integer data type, its range starts from negative 2 billions up to positive 2 billions. You will ask me now, what is negative 2 billions up to positive 2 billions and sizes and ranges? I'll tell you that's what I'm gonna explain to you in this lesson. So stay with me and let's go to see what is data type, sizes, and ranges. But before we go to see what is data type, sizes, and ranges, let's remind ourselves with data types in C++. As we said before, we have fundamentals data types, derived data types, and user-defined data types. Fundamental data types under it integral type, which is under it integer and char, and float type, under it float and double, and boolean type, string data type, void data type. You say it's empty, you explain it in the future. A white character that's belong to Unicode, and we said Unicode, it handle all the languages in the world. For example, Arabic, Chinese, French, Spanish. If you want to write this language between your line of code, the Unicode gonna handle these things, or gonna handle these languages with their numbers and special characters and everything, except the English language, because the English language it's under ASCII table, as we explained before. And after that, we have derived data type, that's under it function, array, pointer, reference, and user-defined under it class, structure, union, enum, and type def. And these two data types, derived data type and user-defined data type, as we said before, don't think about them now, because they have their specific lessons in future. And now let's go to see what is ranges and sizes in C++. So we will start with standard integer data type, and its range, as we said before, starts from negative 2 billions up to positive 2 billions, and its size in the memory for bytes. So it's not ideal to use standard integer with small values, because you're gonna book a huge space in the memory for nothing. You will ask me now, what kind of data type should I use to store in my variable a whole number? Because as we said before, the float buoyant and the double floating buoyant data types, they use for storing numbers with some fractions or decimals. But if I want just to store in my variable a whole number, small value, but whole number without fractions and decimals, and you don't want me to use standard integer because it's range big, I'll tell you, stay with me, that's what you're gonna know in this lesson. And after that, we have floating buoyant, and floating buoyant, its range starts from 1 decillion buoyant some fractions followed by 34 zeros up to 3 decillion buoyant some fractions followed by 34 zeros, and its size in the memory for bytes. You will ask me, what is decillion? I told you decillion is bigger than trillion. We have million, 7 digits, and we have billion, 10 digits, and we have trillion, 13 digits, and after that it's come decillion, and decillion it's around 35, 34 to 38 digits. And we have double. After that, double, it's from name, it's double the float, and starts from 2 centillion buoyant some fractions followed by 309 zeros. Can you imagine how big is it? As I said before, double, we use it usually for precisely defined number, for example, accountings and banks numbers and these things. So even the float number or float buoyant number data type, it's big. You can imagine, if you want to imagine and see in front of your eyes, you can write on paper 1 buoyant 17,549, and after that, right after this number, write 34 zeros. You will imagine when you see this number in front of your eyes on the paper, how big is it, the float buoyant. And as we said, we stop here in double floating buoyant. It starts from 2 centillion buoyant some fractions followed by 309 zeros up to 5 centillion buoyant some fractions followed by 309 zeros centillion. And this centillion is bigger than decillion. And its size in the memory, the double its size in the memory, 8 bytes. And I don't want you to memorize these things and go open your notebook, write decillion, centillion, 4 bytes, 8 bytes. No, I want you to bring your snack and coffee and tea. Understand that there are something called ranges and sizes of data types. It's about understanding. I don't want you to memorize it and write it on your notebook. And after that we have char character. Its range starts from negative 128 up to positive 127, and its size in the memory 1 byte. And we have void no values. Its range, like, it doesn't have any range, it's empty. We said we'll explain it in the future. And after that we have string. Actually, string, we cannot represent it as a numbers, we cannot represent it as integer and float and double, because the string in the end is text. But the scientists and the people that create these things, they say we can call the string range centillion, like the double. We can call it centillion, but it's not common. I write it here for you. Not common to say about the string centillion, because in the end it's text. Yeah, you can put in the text numbers and special characters or whatever you want, but in the end it's text between double quotation. But as I said, you can call this centillion, as the people said, or the people that create these things, they said we can call it centillion, and its size in memory 40 byte. And after that we have boolean, its range as 0 or 1, and its size in the memory 1 byte. And the last one, white character, which is Unicode, its range implementation defined, and its size 2 or 4 bytes. Of course, now you ask yourself, what this range implementation defined? Actually, these ranges and sizes of data types, it's changed from operating system to operating system, from computer to computer. For example, if your computer has 32 bits, these ranges and sizes, it will be a little bit less. If your computer has 64 bits, these ranges and size of data types, it will be a little bit bigger. And same with the operating system. For example, if you use Windows, these ranges and sizes, it will be a little bit higher. And if you use Linux, it will be more higher and bigger. If you use Mac or iOS, it will be these sizes and ranges of these data types are more less. And that was implementation defined. Implementation defined, it's mean data type range is changed from operating system to operating system and from computer to computer. For that, they wrote white character range implementation defined. White character, it's belong to Unicode, and Unicode table, it's huge, and it's handle all the other languages with their special character and numbers. For that, its range implementation defined. Why all these data types are implementation defined? All these data types, their ranges and sizes change from computer to computer and from operating system to operating system, as we explained right now. So that was implementation defined. And now let's go to see what is type modifiers, because we can modify on some data type. We can modify the range and sizes of some data types by type modifiers. So type modifiers, what are type modifiers? All right, we can modify some of the fundamental data types by using type modifiers. There are 4 types modifiers in C++: sign, unsigned, short, and long. If you focus here, some of fundamental data types, some of primitive or fundamental data type, not user defined, not derived data type, just some of the fundamental data types. And there are 4 types modifiers in C++, as you said: sign, unsigned, short, and long. We can modify the following data types with the above modifiers: integer, double, and char. These are the 3 data types that we can modify them. We can modify the integer range, and we can modify the double range and the character range. Just these 3 data type we can modify them. We cannot modify float, we cannot modify boolean, we cannot modify void, we cannot modify string, we cannot modify also white character. So we just have 3 data types that we can modify them, and these 3 data types are under fundamental data types as we take them in the beginning of this lesson. So let's go to see how we can modify these data types. So it starts with integer data type. First one, we have short integer signed data type. Its range start from negative 32,000 up to positive 32,000, is size in memory 2 bytes. So this is the ideal data type that we should to use it in our previous program and our previous lessons, because that standard integer data type that we use it and its range start from negative 2 billions up to positive 2 billions, it's not ideal to use it with that small values. If you use that standard integer data type in our program all the time, that's lead to make our application performance slow. And it's also rely on your application. If your application going to display negative numbers for your clients or user that they will use your application, going to display for them negative numbers, so you have to use sign. But if your application not going to display a negative number for the user or the clients that they use your application, so you will use short integer unsigned data type. Its range start from 0 up to 65,536, and its size in the memory 2 bytes. And if you ask me now what is the difference between sign and unsigned, I will tell you sign, it's allowed to you to store negative numbers in the variables, and unsigned is not allowed to you to store negative numbers in variables. And after that we have integer sign, standard integer sign, and its range starts from negative 2 billions up to positive 2 billions, and its size 4 bytes. And we have integer unsigned, its range starts from 0 up to 4 billion. Compiler erase for you with standard integer unsigned. The compiler erase for you the negative numbers, negative 2 billions erase it for you, but double it for you and give you big range like 4 billion, but all of them positive numbers. And also its size in the memory 4 bytes. And after that we have long integer sign, its range starts from negative 2 billions up to positive 2 billions, and its size 4 bytes. Long integer unsigned, its range starts from 0 up to 4 billion, and its size 4 bytes in the memory. You will ask me now, what is the difference between integer sign, integer unsigned, and long integer sign, long integer unsigned? I told you the story, it's big and long, and it's not worth it even to know it. It was just to give you a little bit clue. It was because of the old computers. Before it was 16 bits and 32 bits, and now the computer is 32 bits and 64 bits. So the story is not important. If you're interested in it, you can search and Google it online, but I told you no need to search about it because you will waste your time for nothing. And after that we have long integer sign, its range negative 2 power 63 up to positive 2 power 63 quintillion. This quintillion is like decillion and trillion and centillion, but quintillion, it's before decillion. It's between trillion and decillion. And its size in the memory 8 bytes. The long integer signed, its size in the memory 8 bytes. And after that we have long integer unsigned. It starts from 0 up to 18 quintillion, and its size in the memory 8 bytes. And now let's see another data types that we can modify them in the memory. We have that we can modify the range. We have char signed, its range starts from negative 127 up to positive 127, and its size in memory 1 byte. We have char unsigned, its range starts from 0 up to 255, and this is the biggest number in 1 byte, so its size in memory 1 byte. And we have double signed. Double doesn't have unsigned, but we have double and long double. We have double signed, we already explained before. It starts from 2 centillion point some fractions followed by 309 zeros up to 5 centillion point some fraction followed by 309 zeros centillion. And we have long double signed, not unsigned, signed, because the double is not stored inside negative numbers. Double just positive number. So we have long double signed also, but its bigger range starts from 7 centillion up to 10 centillion, also followed by 309 zeros, and both of them, their size in the memory 8 bytes. And now let's go to code on Visual Studio and see how we're gonna write and declare these data types. Alright, this is Visual Studio. First we have note. By default everything is signed, as we said in the beginning of this video. Everything by default is signed. For example here, integer or sign integer. Integer or sign integer are same, and their range starts from negative 2 billions up to positive 2 billions. So if you write it integer or sign integer are same, which means if I take this sign, it's same like the upper one. So integer and sign integer are same. And after that we have unsigned integer, that is range starts from 0 up to 4 billion. And after that we have short integer and short. Short integer and short also are same. So if you want to use short integer, it's better to use short keyword, and its range start, or their range start from negative 32,000 up to positive 32,000. We already explained it before. And after that we have unsigned short integer, unsigned short, also are same. And we have signed long integer, and long. So if you want to use signed long integer, it's better to use long keyword. It's same like the upper ones. And we have unsigned long and long integer, and we have unsigned long integer. It's same like unsigned long. So if you want to use unsigned long integer, it's better to use unsigned long keywords. And after that we have long double, we have double, and we have long double, and we have sign card, and we have car. Sign car is same like a car. So if you write car, it's by default sign. As we said, everything by default is sign. And the last one we have unsigned car. I know this lesson a little bit complicated, but the goal from this lesson, from the beginning till this point of this lesson, that I want you to know that there is different ranges and sizes for each data types, and you know also how to use the correct data types that fits your values. And now we have this code. In this code I want to show you some numbers and some errors in case you face it. I don't want you like to panic or say why it's look like this. Here first we have double distance, double like data type double. We use the keyword double and distance, the name of the variable, equal 56e12. When you see 56e, this E letter between these numbers, don't panic, it's exactly same, or it's equal to 56 multiplied 10 power 12. And here we use short data type keyword. Short data type keyword is strange, we say it starts from negative 32,000 up to positive 32,000. And here we assign to this variable that's belong actually to short data type, we assign to it variable out of the range 34,000. So the compiler should give us error when we did run, error out of the range. But unfortunately there is some compilers not give you error. There is some compilers not let you even run. If you did run directly, the compiler stop you and give you error out of the range. And there is some compiler, they run for you the program, like when you did run the program, it's work, but the compiler did truncate for the wrong number. For example, here wrong value, we have 34,000 and the maximum number of the range of data type, short data type, is 32,000, the maximum 32,000, positive 32,000. So sometimes the compilers do truncate and give you the correct maximum number of the range of the short data type range, which is 32,000. And sometimes they do truncate to the number and give you any another wrong number, for example 26, 36. Now when you do run, you will understand what I mean. And the last line of code, we have unsigned integer, and after that we give it a, the name, the variable name, it's a, equal negative 10. The compiler should give us error, can only store positive numbers, because unsigned, we say we cannot store negative numbers with unsigned data type or unsigned keywords. So let's do run to this program to see how it will look like. Perfect. Here 56e12, it gives us 5.6e plus 13 digits, and this one short v equal 34,000, so the value it was out of the range. The compiler do truncate and give us any another wrong number. The compiler give us 26,361. Yeah, it's close to 32,000, the correct maximum number of the range of the data type short range, but it's not the correct one. It's close to 32, but it's not the correct one, which means the compiler return for us a wrong results. And the last one here, unsigned integer a equal negative 10, and we say we cannot store negative numbers with unsigned, so the compiler bring us the maximum number in the range of unsigned integer, and it's also wrong results. And now let's go to the second code, and this code gonna display for you the sizes of each data type by using sizeof keyword. We have in C++ programming language, we have keywords called cof, and after that in each bracket we open bracket or parentheses, we put the name of data type, and when we did run, the compiler going to display for us the size, how many bytes of this data type. Here write cout less than the size of the bool data type is, and less than I use size of a keyword, I put bool data type keyword. If I did run now, the compiler will display for me the size of the bool keyword. And same with the char, with the showed integer, long, and float, double, and the last one string. Let's do run to this program. Perfect. The size of the bool data type is 1 byte. The size of the char data type is 1 byte 2. The size of the short data type is 2 bytes, and integer data type, the standard one, is 4 bytes. And the size of the long data type is 4 bytes, the long data type is 8 bytes, the float 4 bytes, double 8 bytes, and the string, it's the last one, the size of the string data type is 40 bytes, as we explained it. And now let's go to another code, and this code gonna display for you the minimum and the maximum numbers in the range of the data types that we can modify them, and other data types we cannot modify them, but we can display the range. For example, here we have float, but let's start from the beginning. The char range, to see or display on the console screen the char range, we will use this keyword, char underscore minimum, all of them uppercase or capital letter, and char underscore maximum to display for you on console screen the maximum number in the range of the char data type. And here we have unsigned char range, we use u letter, and after that char underscore maximum, all of them uppercase. And we have here short integer range, short underscore minimum, we write it without the all of them uppercase. short underscore maximum to display the number in the ranges of data types that we can modify them. While float data type, we cannot modify its range, but here we can display its range, and also we can display the negative float number range. For example, float negative range. To see the float negative range, to display it on console screen, you will use subtraction or minus sign before this keyword FLT underscore minimum and minus FLT underscore maximum. You will use this keyword, and before it you will put minus a sign, subtraction sign. So let's do run to this code. Perfect. The compiler display for us the number in the ranges of the data types that we can modify them. For example, here we have char range. Its range starts from negative 128 up to positive 127 as we take it in the slide. And unsigned char starts from 0 up to 255, and this is the biggest number in the byte. Short integer range negative 32,000 to positive 30,000. Unsigned short 0 to positive 65,000. And we have here the standard integer range. It starts from negative 2 billions up to positive 2 billions. And unsigned integer range, the standard one, unsigned integer range, starts from 0 up to 4 billion. And the float range, float, we cannot modify its range, but we can display its range. Float range starts from 1 decillion, as we said, point some function, and e, we expanded this e multiply 10, and negative 38 zeros, like followed by 38 zeros, sorry, up to 3 point some functions, and this e multiply, we say 10, positive followed by 38 zeros. And here we have float negative range. To display the float negative range, we use just this minus sign, and it gives us the same numbers but with negative, or it will be, the compiler will put for you negative sign before the numbers in the range of the float data type. And that was the last code. Now let's get back to our slides. We have a small homework. We have to take it before we finish this lesson. Our homework today, it's easy. I want you to revisit all the previous homeworks and choose the proper data type according to their values. I want you to get back to all the homeworks that we take them before, right, and choose the proper data type according to their values. And that was the lesson of today, guys. See you next lesson. Ciao.